Hello, everyone, and welcome to another exciting session of LambdaTest XP series. Through XP series, we deep dive into the world of insights and innovation, featuring renowned industry experts and business leaders in the testing and QA ecosystem. I'm Harshit Paul, Director of Product Marketing at LambdaTest, and I'll be your host for this session on Fast and Furious, the Psychology of Web Performance. Joining us today is Mary Cruz, Senior Developer Advocate at K6 Grafana Labs. With over a decade of experience, Mary wears multiple hats as a tech blocker, an accessibility advocate, and an online course instructor at the Ministry of Testing, as well as Test Automation University. Hi, Mary. It's an absolute pleasure to host you. How about you let our viewers know more about yourself?
Yeah. Hey, Harshit. Yeah, thank you again for having me today. I guess just to add to that, so yep, I've been doing software testing for over 10 years, but last year I decided to do a career switch. So now I work as a developer advocate for Grafana Labs. And yeah, I'm currently based in London, but originally I'm from the Philippines. So I do enjoy photography. So, like outside of work, I like to take pictures, reading books as well. And yeah, just trying out a bunch of different cuisine as well. So, big, massive foodie. But yeah, I'm excited to give a talk about this whole psychology behind waiting and why is it that people are irritated whenever they're being sold to wait. So there's a bunch of human factors, and we'll try and link that back to web performance.
Right. And speaking of web performance, right, from internal stakeholders to external ones, performance is everyone's concern. And being everybody's responsibility, there are all sorts of opinion which come into play. And Mary would help us understand the psychological aspects of web performance from different angles. Why do performance matter over design? Why do slow websites trigger irritation? What's the impact of a 10-second response time on user satisfaction? And we'll also look into, as Mary said, tips to optimize scenarios where speed optimization is not as visible and comes across as a challenge. But before we begin, we would like to highlight that we do have some fancy slides prepared for this session. So if you're listening to this episode through our podcast, feel free to head out to LambTest YouTube channel and get the access to the entire full video recording of this session. Having said that, Mary, the stage is yours.
Nice. So let me just quickly share my screen. Okay, so again, I've mentioned today I'll be talking about the psychology of performance, and I'm not really gonna share any new performance tool, or I'm not gonna share any tips on how to integrate performance checks as early as possible, or any other technical guides. And while those are all important and things that we should know, I think that it's also equally important for us to understand the why. So, why do we want faster websites? And why is it a known fact that slow websites irritate us? And why is waiting not an enjoyable activity? So, what can you expect from this talk? So, first, I'll talk about the psychology of waiting lines and what we can actually learn from service businesses and how we can relate that back to web performance. And then next, I'll talk about the different factors that make waiting longer and unenjoyable. Then finally, I'll share some recommended guidelines to improve your web performance, both from the subjective and objective view. Probably not useful if you're listening to the podcast, but if you're watching it on YouTube, I've got a QR code here that you can scan. So if you want access to the slides after, then feel free to take a picture of this QR code. But to start things off, I guess you might have heard about this famous quote which goes, "The first impression is the last impression." And as we know by now, the first impression is really important because it influences our thought process about everything, even web performance. And David Meister, so he actually wrote this article called The Psychology of Waiting Lines. And as part of this article, he actually included this quote from Federal Express Service. So the quote says, "Waiting is frustrating, demoralizing, agonizing, aggravating. annoying, time consuming, and incredibly expensive. And as humans, we've all been exposed to long waiting times. At a very young age, we've always been taught to wait for our turn when, let's say, we want to play with a toy being shared. And this even extends to our adult lives when you try to buy the latest iPhone, or even when you're trying to get the COVID vaccine. And this even extends virtually. So, for example, if you're in a situation where you want to buy a ticket to see your favorite band, you have to wait for a long time virtually to purchase that ticket. So, waiting is an activity that we are all exposed to, but it doesn't mean that we actually enjoy it. And here's just a personal story. So I remember last year we were eating at TGI Fridays with my daughter and my boyfriend's family, and I just remembered that we were waiting for such a long time. The kids didn't notice it, so they were too busy playing. My daughter was completing an activity sheet. So the atmosphere from the kids, it's very different. And then you look over at all the adults, and all the adults were all frustrated because we were seated late. The drinks arrived late, the food arrived late, and then even asking for the bill took such a long time that afterwards, our perception of TGI Fridays have completely changed. And as part of the article that David wrote, The Psychology of Waiting Lines, he actually explained that the waiting experience in a service facility, this significantly affects our overall perceptions of the quality of the service provided. So the food that I ate from TGI Fridays, that was good. That was consumed well. But because of the long wait for the service, that have still influenced my experience negatively. And this can be explained simply by this first law of service. So, according to the first law of service, satisfaction is perception minus experience. So, what this means is that if you expect a certain level of service and you perceive that service to be higher, then ultimately you become a satisfied client. But on the other hand, if you expect a certain level of service, but then your actual experience is quite disappointing, then you become a dissatisfied client. So, with my TGI Fridays experience, I was expecting this certain level of service because I've eaten there before without any waiting problems. But because of that one negative experience, that resulted in an overall dissatisfaction that up until now, I've never set foot to another TGI Fridays restaurant. And this also ties in nicely to David's second law of service. So he said that it's hard to plan catch up ball. Now, what this is saying is that any impression that's created in a service encounter that will actually influence the rest of the interaction. So this means that first impressions do count. So similar to websites, this like these two laws apply since most websites also offer a service online. Now, when we want to distinguish, or when we want to talk about speed or time, I think mostly people talk about the objective measure. But actually, there's two sides to it. There's the objective side. So, this is when we talk about measuring how fast a website loads in a specific number. And then there's also the psychological side. So this is the way that your users perceive time. So even though time moves in a specific measure, the way your users perceive it might be different. So this is the psychological angle. Now, from this psychological angle, we can think of waiting as divided into two different phases. We have the active phase, and then you have the passive phase, or the passive waiting. Now, active phase, this happens when you're engaged in an activity. So you're in a state of flow. You don't really realize that time is taking a long time because you're very engaged and you're in this state of flow that nothing really matters. But on the other hand, when you're in a passive waiting, this is when you don't have control over the waiting time. So this is when you're aware that time is moving slowly because you're bored. And this explains why waiting in line, for example, feels like a boring activity. But there's actually several different human factors that explain why waiting is not an enjoyable activity. So I'll explain some of these different factors, with the first one being occupied time feels shorter than unoccupied time. So this can be explained simply by the saying, a watch pot never boils. So something appears to go more slowly if you are actively waiting for it rather than engaging in other activities. So, a perfect example of this is, let's say, waiting for your food to be microwaved. The waiting time feels like forever, especially if you're not doing anything. So, I know when I microwave my food, I try to occupy my time by doing something else. So, I can feel that the time is moving faster. Now, if we relate this back to waiting on the web, if you visit a website and the actions are taking a long time without any feedback of what's happening, then waiting for something to load online feels longer and unenjoyable. A common technique, though, that different companies use is to try and occupy the user by showing something fast or relevant, by um, like showing something that is, I guess, useful to them immediately. And they try to provide useful feedback even though the information is not presented yet. So, a perfect example, Slack, which we all know. So, Slack provides this skeleton framework to show users that something is loading. So, they use animations when messages are being loaded, and they have like these different, like funny messages as well to make the users feel engaged so that the user feels occupied while they wait for, let's say, the background API calls to complete. Another example, so this is the K6 cloud. This is still the legacy. So this is the legacy application, but it's the same setup in Grafana Cloud K6. But basically, whenever you run a test, especially a load test that has a high number of virtual users, the setup stage might take some time because it will try to load all the necessary resources that's needed for that particular test. So to occupy the user's time, what we do is we show animations um, to also provide them progress of what's happening so that at least they know that they're not waiting for anything that's not useful. And then the second explanation, people just want to get started. So when it comes to, let's say, eating at restaurants, you feel valued already when you feel that you get seated quickly, even though that the actual service of the food hasn't started yet. So to fill in the gap, waiters hand out the menu to you immediately to give you a feeling that, hey, I remember you. We're gonna be I guess like quite a bit of time in terms of like giving you the main course, but here's the menu. If you want to have some starter, if you want any drinks to start with, then you can get started. Now, if I relate this back to performance on the web, what you can do is you should show something as quickly as possible so that users can see something quickly and they feel that their experience has started. However, when you show something quickly, you should also prioritize critical content to make the user experience meaningful. Because whenever a user visit your website, when they see the information that they want immediately, even though the rest of the page hasn't loaded yet, they feel that their experience has already started. So one way to do that is by tracking a very important core web vital called largest contentful paint. So, largest contentful paint, or LCP for short, it's an important metric for measuring the perceived load speed because this provides a measure as to when the largest content or when the main content has likely loaded. So if you have a fast LCP, this helps reassure the user that the page is useful because they can see the content that they want immediately. Third explanation. So anxiety makes waits seem longer. So a perfect example that I can think of, if you're a parent and you take your child to the doctors for, I guess, their routine vaccination. If you're a first-time parent, this can create anxiety for both you as a parent and your child if you are just waiting without knowing when the appointment will start. So to overcome this, a common practice is someone will let you know how long the wait would be. And it's also quite common to have activities for the kids so that they can get distracted. Going back to web performance, negative interaction can trigger someone's anxiety. So, slow website is actually one of the main reasons for causing stress online. If there are images that are not loading or the page in itself hasn't provided any feedback after a certain action, this can quickly trigger an anxious user. So, what can you do? So, going back to the web, you can try to make improvements such as optimizing your images so that the page can load quicker without having to sacrifice the quality of your image. You can also minify the CSS or JavaScript files so that it can reduce the load times and the bandwidth usage on websites. And another way to reduce anxiety is to improve the visual stability. So, one metric that you can use to improve visual stability is the cumulative layout shift or CLS. So, this is one of the core web vital metric as well, similar with largest contentful paint. And this is an important user-centric metric for measuring the visual stability of your pages. So, the lower your cumulative layout shift score is, the um, lower the visual instability is. So, this provides a better user experience because because it has reduced unexpected layout shifts. The next reason is uncertain waits are longer than known waits. So if, for example, I told you that you have to wait, but then I haven't provided any reason why you have to wait. So your expectation is not being managed already. And then the waiting time feels longer, which again correlates to higher anxiety. So this is sort of related to the other reason. So as an example, when there are train delays, but there's no indication of how long the delay will be, you get irritated more. Um, However, if there is a time added next to as to when the next train is most likely to come, so if it says 5 minutes delayed or let's say 10 minutes, you accept the delay better because at least your expectations have been managed. Now, how can we relate this back to web performance? So, one way to do this is you should let users know what is happening. So, when their expectations are managed, their experience is likely to be better. So, you can also provide visual feedback in the forms of a timeline, progress indicators, to convey that there is a certainty to your user. Or, like you saw on the Slack example, even though the application hasn't fully loaded, there's a skeleton framework to show to users that something is happening. Another example is with this providing feedback immediately, is you just have to explain it in a human way as possible. So, as an example, you could see here that there is a very clear reason as to why the waiting is happening. There is a time there as to how long the wait needs to happen. So again, your user feels engaged, and even to them, they feel valued because at least they know that something is happening on the background. So imagine if you're on a page without any feedback and it's just an endless loading spinner, but then objectively the time to wait is the same. So users will feel that that is gonna take longer, even though objectively it's the same, because it's gonna make them feel bored. It's gonna make them, I guess, like in terms of like anxiety, it might increase their anxiety because they don't really know what is happening. The next explanation is unexplained waits are longer than explained waits. So again, this is sort of related to the previous explanation, but the way you can differentiate this is, let's say you're buying some clothes and you go to the till to pay for the item that you bought, and you saw that the person behind the till is not serving any customer, but then they haven't called your name. So because they haven't mentioned, for example, any um, any like explanations in terms of why they're not serving you, you feel that you're not important, and then your anxiety is going high, and then like some people as well, they do get annoyed at these cases. But then from that perspective of the user, of that person waiting behind the till, they might be doing something, but then they haven't communicated that to you. So because of this lack of communication, you feel that you are waiting longer than you're supposed to. So again, if I use the K6 Cloud as an example, you could see that there are clear explanations for what's happening as to why the test run could take a bit longer than you expect. And imagine as well if, these messages are not there. There's an animation, but then there's no human explanation as to why the wait is happening. So you might feel that something is wrong in your connection rather than the application, doing what it's supposed to, and it's just trying to process your application because there's no actual feedback being given to you. Another great example that I saw online. So there is this airline, like a travel booking site called 𝐕𝐢𝐝. So as you can see from the animation, they are showing a list of airlines being searched, which can explain the long wait. There's also a progress bar, but they're also adding a fun element to it. So there's a friendly looking mascot to make the wait enjoyable. Now, the next explanation, unfair waits are longer than equitable waits. So, a good example in the physical world is that if you're waiting in a queue to eat at a restaurant, but then there were people who arrived later who were given priority sitting, this can cause you to become agitated. This feeling of being agitated makes the waiting experience horrible as well. Um, to sort of bring this back to performance on the web, to address this feeling of unfairness, we have rules like the first in, first out, and it's widely adopted to enforce discipline while you queue. So, if you've ever bought some concert tickets, you probably waited to buy some tickets to see your favorite artist. So with this first in first out, um tickets, for example, if they go on sale at a specific time, you log into your account, but then whoever has, I guess, logged in first, they might have higher priority. But then this can still have some issue online, especially with ticket bots occurring. So, what companies like Ticketmaster, what they've done is they've introduced this concept of a smart. So, to address this, rules like the first in, first out, they are widely adopted to enforce this discipline while queuing. So, if we translate this back to web performance, you probably waited to, let's say, buy tickets to see your favorite artist. So for example, if tickets go on sale at 10 a.m., you log in into your account, and normally whoever logs in first, they do get priority. But still, in some cases, that is quite difficult to manage because of ticket bots. So what companies like Ticketmaster have done is they've introduced this concept of smart queues, which basically acts as a virtual line to prevent ticket bots from buying tickets in a matter of seconds. So, from a web performance perspective, a recommended guideline, and this is especially useful if you are an if you are an e-commerce website and you're trying to handle the amount of customers that you have. So, one way to do this is by implementing this queuing system in which you process the customer's order in a manner of like when they enter the queue to avoid any feelings of unfairness. This doesn't necessarily improve, though, the actual waiting times, especially if you have a high number of customers waiting. However, it still improves their experience because their expectation is managed in terms of how long they have to wait. And this can also help manage your website's traffic. So there is a less chance of your website crashing. So, the next explanation, the more valuable the service, the longer the customer will wait. So, a perfect example is people can tolerate waiting a bit longer at high end restaurants because they know that the service will be more valuable. Let's compare that with waiting at a fast food chain. So imagine you're waiting for 45 minutes to get a food or to get a burger from a fast food chain. You'll definitely be experiencing your experience negatively because you shouldn't be waiting for that long if you're waiting at a fast food chain. So back to the web. If you have, let's say, a feature that is valuable and you know that it takes some time to process that. So as an example, let's see like the airline example or insurance. Whenever you try to buy insurances, the first result, and this is like true to most cases. So the first result isn't the result that you actually trust because you want to make sure that you get all the best insurance. So you're willing to wait for that because you know that if you wait a bit longer, you might see a cheaper insurance. So in terms of like other sort of services, it's the same with, let's say, you're applying for a mortgage. If you suddenly get the result that hey, you got accepted for a mortgage, you don't really trust that particular result, so you're much more willing to wait if the if the service is much more I guess useful to you. So, other recommendations, you can explain the weight, you can indicate progress visually, and like you saw with the Hipmunk travel booking site, you can also try and make it fun. Then finally, the final factor that explains why waiting feels longer is that solo waits feel longer than group waits. So when you're standing in line alone, waiting for it feels longer than waiting in a group because when we're in a group, we are more engaged and the less we notice the waiting time. Now, because we do most online activities solo, companies do need to come up with ideas to entertain us while we wait. And a great example of this is the Dino game that Google developed, which is built in on Chrome. So whenever a user attempts to browse while they're offline, the browser notifies the user that they're not connected to the internet. And then this dinosaur game is also displayed on the page. So it keeps you distracted and it also keeps you entertained. So again, in terms of recommendation, it's already quite similar. So hopefully by now you can see that there is a common theme to it. So make it fun and also provide immediate feedback to your users. Now, there's also other recommendations that you can utilize to improve the web performance. So I'll go over these other recommendations one by one. So the first one is you can load above the fold content first. So this is basically what your users first see when they load your website. So what you can do is you can display the critical content above the fold so that these are the content that gets displayed, I guess, immediately to your users when they first visit your website. You can also try to lazy load your content to reduce the initial page load for your page and then replace it with a placeholder image, or you could replace that with a skeleton to indicate to users that there is content to be loaded. So when they finally scroll down to that page, that placeholder or that skeleton image will be replaced by the actual image. This is something that I guess we all know, but adding button states to your buttons also let your users know that something is indeed happening. So this can also improve the perceived performance whenever they see an immediate feedback whenever they interact with any of the buttons. Funny enough, so the importance of animations, the animations also do matter. So I've got this image here, and to me it looks quite similar. So you've got the first image without like the person below being picked up by the UFO, but then the image on the right has that extra feature. So with this small changes, you could see that the image on the right is much more fun. So users are more likely to basically go with that particular animation. So again, animations really do matter. So I've mentioned already that if you just use a lot of like um endless loading spinners or animations that aren't really providing that useful feedback, then those animations won't really be useful. So make sure to choose your animations wisely. And then finally, even the font you choose, so it actually matters. So I've read this study from keycdn.com. So they have a blog post there which basically outlines the impact of different fonts to the overall load times of your page. So if you're designing a website and if you have some custom fonts, you need to be careful that those fonts might load slower depending if your user has installed that font or not. So it's much better to stick with fonts that are universal, because you know that that won't have any impact to the performance. Now, all the different factors that I discussed, it actually shows that the waiting experience makes all the difference. So, what actually drives us crazy is not the actual waiting at all. So, you could see that we're actually willing to wait, but it's when we start to experience boredom and anxiety that makes waiting unenjoyable. So, how we feel when we wait often matters a lot more than the duration of the wait. Now, when we talk about web performance, the objective performance is still very important. So, page speed remains one of the key indicators that you need to look out for regarding web performance. And Jacob Nielsen actually wrote an article called Response Times, the Three Important Limits. And in this article, he summarized that there are three important limits when it comes to response time. So the first is zero point 0.1 second. So this is the limit for having the user feel that the system is reacting to it instantaneously. So for example, if I'm typing on a keyboard, I should see the feedback immediately, and there shouldn't be any special feedback necessary. And then the second limit is 1 second. So this is the limit for the user's flow of thought to stay uninterrupted. And then anything longer than that, users will start to feel that, okay, something is happening, it's taking some time. But if it's 1 second, our limit of thought is still uninterrupted. And then finally, the third limit is 10 seconds. Although I can argue that this is probably now much more lower because we're very impatient nowadays. But basically, in this article, Jacob said that 10 seconds is the limit for keeping the user's attention. So anything longer than 10 seconds, you need to be providing feedback indicating when that particular operation needs to be done. So, ideally, we know that websites, should load immediately. So, I think Google recommends like 1 to 2 seconds. However, we're not all Google, and in some cases, it might not be achievable, especially if you've exhausted all improvements to improve the objective measure. So, what you can do is you can take that a bit further and also make improvements from the psychological side, so from the perceived performance of the application. So you've made some improvements. How do you then know that that these are successful? So how do you measure the perceived performance as well as the objective performance? From an objective point of view, it's quite easy because you can look at the metrics. So I spoke about the core Web Vital metrics, and there's a bunch of tools out there that can help you measure the Web Vital metrics, such as Google Lighthouse. But you have to also keep in mind that Lighthouse uses lab data, which is collected from a controlled environment, and it uses predefined devices and network settings. So what you need to do is you should also complement that with tools that are using field data, because this is actually what your users are seeing. So tools like Page Speed Insights, Chrome User Experience Report, even Google Search Console can help you with these. And from a Grafana perspective, we also have Grafana Faro that provides a real user monitoring solution that can help you keep track of the objective performance. From a subjective or perceived performance, I think using the same metrics, so the Web Vital metrics, can give you an indication. Although, what I would highly recommend is for you to ask your users directly how long it felt, for example, to them for your page to load. So you can conduct some surveys, or if you have a team that conducts some user research session, then you can participate in those sessions and then observe how your user feels while they are using your application. So, some final words before I end this session. When we talk about web performance, it's very common for us to make improvements on the objective side. And these improvements are all valuable. However, we shouldn't stop there. So, it's very equally important to understand the psychology behind waiting, the human reasons why people don't like to wait, and how the perception of a performance is actually not the same as the actual performance. So, perceived performance then can be seen as the total of the expected performance, the user experience, and then the actual performance. So, user experience is still very much an important factor. Now, when you employ additional guidelines to make your website feel fast to your users, then you can ultimately improve the user experience. And yeah, that is it. So I hope that after this session, you can come up with new set of heuristics, new set of test ideas that can also help you cover the perceived performance of your application.
Right. Thank you so much, Mary, for that session. Tremendous slides, powerful message, and pretty relatable as well to everyone, I believe. I will just try to turn off my camera. I feel like my net is a bit sluggish at this point. But yeah, having said that, I hope my audio is coming out clearly. Is it, Mike? Perfect.
Yep, all good.
So, okay, perfect. I saw you nodding, so all right. So, as you also mentioned, web core vitals have always been a part of, Google's priority list as well, because at the end of the day, Google also wants better user experience, and if your site is not catering to that, you have a lot to work upon, right? And the parts where we
Mm-hmm.
talked about, uh, you know performance not achievable to some extent, there are some challenges,
Yeah.
and those workarounds that you presented, especially the Slack example and other examples as well, where we are able to keep those user perception in mind and give them something to hold on to while they wait for the main content to come across. So that was really handy. I do have some questions. I'll just quickly pose them towards you, right? uh,
Yeah.
Speaking of performance, which technical factors significantly impact user perception of wait time, and how can they be identified and mitigated?
Yeah. So I think the really main thing is if there are any, let's say, background API calls that are taking a long time, especially if you're trying to process a high amount of requests. So from a user perspective, I think this can be mitigated if you try to provide some immediate feedback. So whenever you try to explain to a user that, hey, this is taking a while to load, so as long as you explain it um, in a human, I guess, reason to your users, then they're actually much more forgiving than, let's say, without any explanation at all. So this also depends, I guess, on the application that you are testing, because I know with some applications like I mentioned the mortgage or the insurance quote. So there are some cases where you actually want users to wait because you want to give them the best results possible. And again, I mentioned already a while ago that if, for example, you return the first result to your users, then they might feel that that wasn't actually the best result. So some of the technical factors around background API calls taking some time to complete, again, that can be mitigated by providing feedback. Um, I've seen a lot of websites as well that has a lot of unexpected layout shifts, especially if you're trying to access that on a mobile device. So websites with high cumulative layout shift, that means that they have a lot of elements that move a lot. So that can cause high anxiety to your users because let's say I've already navigated to the element that I want to focus on, but then suddenly there were other elements prior to that that got loaded, and then suddenly my whole shift has been changed. So then I have to find the element that I want to look at it, that I want to look again. So if you try to reduce your cumulative layout shift score, be smart with how you employ some lazy loading techniques, then that can significantly improve the user perception. So I think like a common misconception or like a common um technique that people have done in the past is with lazy loading, they just defer everything whenever it's needed. And while that's useful because that can help your page move faster, but then from a user experience perspective, if you're loading them um if you're loading them at a later stage, but then the view has suddenly shifted, then that can impact the user experience. So a smart way to do it is, maybe you can replace like a low resolution image with an actual image whenever the user needs it. So be smart as well with how you employ your lazy loading techniques.
That makes sense. And, speaking of this, how do we optimize our CI/CD pipeline for consistent and reliable performance across varying user traffic conditions, particularly during peak usage times?
Yeah. So here at K6, so we've actually written an automated performance testing guide. I'm not sure what the best way to share this, but Harshit, I can share the link over to you. But basically, as part of that guide, we've added tips, for example, on how you can write different types of performance tests. Because one misconception that people might have is performance test is all about load testing. But actually, when we think about load testing itself, you can do smoke testing, you can do stress testing, you can do soak, you can do spike testing. So depending on the performance test that you want to execute, you can be smart about, for example, okay, on a develop or on a pull request environment, I want to run my smoke test on each commit. So the smoke test can just be validating the experience of one user. And the other important thing as well is you need to use tools that are compatible or that can integrate well with into the workflow of your teams. So from a front end performance perspective, there's tons of libraries out there that can help measure the web vital metrics, and that can integrate to your testing framework of choice. So you can have a look at Lighthouse, or you can have a look at, I guess, depending on what testing framework you're using. If you're using Cypress, they have a plugin that can integrate to help measure the web vital metrics. If you're using Playwright, they also have some feature for that. Or if you're using K6, we have a K6 browser module that you can use. So again, you have to choose a tool that can integrate well into the workflow of your teams. And depending on other environments that you have, so let's say you have a QA environment, you can then run your average load tests. And if you have staging environment, so at least before you push something to production, you can have that increased confidence that depending on the user traffic, you have a job for running average load tests, or you can even have a job that you can execute manually if you want to perform some spike testing or some smoke test, or some soak testing. The important thing to do, so if you're integrating all these performance tests as part of your CI/CD pipeline, is you need to track the performance metrics continuously, because you need to have a trend of data that you can observe, that you can understand, so that you can make some improvements. And that way, that can also help you check whether the improvements that you have made will have some impact to your actual product. So you can have a look at, I guess, how the trend goes downwards, because the goal is to have the metrics, I guess, as faster as possible, so you can um, check whether or not the improvements that you have done have actually contributed to the speed of your application.
Right. And as Mary pointed out, we would be attaching the reference material to add more on top of this question over our YouTube channel where this video would be uploaded. So you can find that reference material in the YouTube description. So by all means, feel free to head out and check it over there. Heading on to the next question, how can teams integrate performance testing into DevOps? Ensuring continuous optimization aligned with rapid deployment cycles.
Mm-hmm. So with this, like the first thing or the first step um that I would share is to really start with small improvements. If you can start early, I think that is always the goal. But if you're working on a project that is already midway, so it's already live in production, you can still start with small improvements. So you can focus on the pages that are, I guess, in terms of traffic. So the pages that are high in traffic. So you can look at some analytics that you have. So I've shared, for example, that you can use Google Analytics, or you can use Google Search Console to check which of your pages are the most visited, and you can check what the web vital metrics are for those particular pages. So whenever you try to make some small improvements, I think that can make the experience a bit better. So as long as you're making small improvements continuously, monitoring what the impact is to your application, and then maintaining a trend of data that you can then use, I think that's a good way. um Another way that you can do is you need to discuss all these performance requirements earlier. So I know in our industry, for example, we distinct functional and non-functional requirements, and people might perceive that as functional requirements being important, and non-functional requirements are requirements that are good to have. But actually, we need to rephrase that and just call everything as requirements, because at the end of the day, performance or accessibility or security should also be discussed as earlier as possible, because they should be as equally important as the functionality of your application. So if you discuss this as early as possible, try to bring in your concerns to the team as much as even if the application isn't still fully deployed, then that's much better rather than waiting for, I guess, everything right at the end when you've already deployed something. So make sure to talk about it early.
Yeah, couldn't agree more. Especially, so you gave a very interesting example about the anxiety as a parent, right? I guess another anxiety example, which is very relatable, is when you deploy a hot fix and you're waiting for that regression suite to come clean. So, as you said,
Yeah.
better to keep these things lined up on the early phases rather than dumping everything towards the end, of course,
Yeah.
right? Speaking of the modern web, third-party services cannot be missed out, right? So, when we integrate
Mm-hmm.
third-party services into web apps, what technical measures should be taken to prevent performance bottlenecks and ensuring that there is a seamless user experience?
Yeah. So this is quite tricky because with third party scripts, you essentially, so these are out of your control because these are maintained by other services or by other companies. But what you can do from your side is you can make an audit of all the third party scripts that you have, and then really identify, okay, do I really need this particular script? Because if visually that script is making your page look nice, but then it's making your page super slow, then you need to decide as a team which one is more important. And as you've seen in this presentation, sometimes the look of your application, but then if it's slow, if it's sluggish, if there's no feedback, then the user experience is still not good. So if you can remove any scripts that are not really essential, then you need to remove those. One other thing that I can think of is, because I mentioned the lazy loading technique. So you can also try to employ some lazy loading techniques for the third party scripts. So one example that I can think of is whenever your page has loaded, you can use lazy loading to load the third party scripts only when they are needed. So at least it's not slowing the page down all the time. You can also try to load them like asynchronously, like on the background. So it doesn't really, I guess, interfere with the rendering of your entire page. So by employing like these additional techniques, like you can just lazy load them, for example, when your users actually need them. So at least you're only showing what's critical to them when they first visit the application. And I think if you're using like a content delivery network or like a CDN, I believe you can cache the third party scripts, although I'm not exactly sure in terms of like the technicalities of it. But I think you can use a CDN to basically cache the script so that it doesn't really load everything from like the source server. So at least it's cached, so that can reduce the latency and the bandwidth of the requests.
Wow. So yeah, those are all the questions from my end. And while my video is not up, I'm definitely making notes of what you have suggested throughout, right? So a lot of things for me to experiment from this session, and I feel our viewers would also be feeling the same way. So thanks a lot, Mary, for this entire session. Fascinating slides, powerful message conveyed to everyone, and most importantly, thank you so much for taking out of your busy schedule and joining us. Right.
Thank you
Thanks
so much.
everyone to who tuned into the session as well. Right. I would like to thank everyone who tuned in as well. Stay tuned for more exciting episodes in the LambdaTest XP series. Until then, take care. Happy testing. Bye bye.
Bye. Thank you.